Yo, servus. So it's been a long time for me not making the videos, and so today I have this a very interesting question. It's about geometry, and I know you guys, especially those who've been maybe yet done the Form 3, a bit of syllabus that has to do with similar triangles, that has to do with this kind of techniques when you deal with this kind of question. And I'm gonna show you later the solution, which is somehow related to AdMaths Form 4 syllabus solution. And well, of course, please try to do this question, and then we will be right back in a few minutes. Okay, now you have done the solution. I mean this question. And so I'm not going to review this answer at first, but I'm gonna show you how it's exactly done in the Form 4 syllabus method. So what I meant is that we can use coordinate geometry, surprisingly, to solve this problem, but it's kind of a bit complicated because it deals with many unknowns. But later I will tell you it's actually, well, simplifiable. You can simplify it very quickly by, first and foremost, we're gonna have to set up some coordinates for point A, B, C, D, and also P, Q, except M. M, we will use the coordinates of the surrounding points, and then using the concept of point of intersection to find the coordinates of M. So let me show you what exactly I mean. So I scroll down, as you can see, I have copied this diagram and we drew it somehow with the label coordinates. So A, you have 0, comma A, and D is a origin, and then C is B, comma 0, and then B, comma A for B. And then PQ, well, you have no idea which kind of letter you want to put, and you have no idea which kind of relationship you're gonna have, but it's okay, just place it that the P has a coordinate of 0, P. Remember, it's in y-axis in this case, so this is in my apologies. So this is in y direction, and so because of in the y direction, and so we can just try to use here as a y, and so we have to label it at here on the right side, and then here on the left side x. And so we have, in this case, this q, like this case, we have k here as a coordinate. Well, k is, it lies between 0 and b, while p, it lies between 0 and a. K is in the x direction, and then p is in the y direction. So we're gonna use the concept of point of intersection to find M. So notice that we have lines PC intersecting with line DQ. So we're gonna find equation of straight line of PC and then also DQ. So the next step, we're gonna find a gradient of DQ, and then hence you find the equation of straight line DQ is nothing but A over K times X. And then the second one, you will find, of course, the PC. You have a gradient of negative PB because it has negative gradient. And then the equation of straight line PC is this one, negative PBX plus P. And hence you have these two equations, but it just with variables without numbers. It's okay. We treat the letters apart from x and y as the constants, okay? And now we're gonna try to use the fact that y dq, this one, equals to the ypc. We're gonna equate them together so that you will get this equation as a result, this one. And then you will get x, the x coordinate of M, okay, this one, the x coordinate of M is nothing but PBK over AB plus PK. It's okay, it's kind of very complicated. And we can substitute this XM in YDQ, either YDQ or YPC, and I suggest you to use the simpler one. Using the YDQ, you will get eventually, which is this one, A over K times this thing, the entire thing, and then you can cross out the K here in this case, and you will get this one eventually, this one, A BP over AB plus PK. So you have XM and then YM, and you can use them for, well, later you will use them. It's very important. Okay, now we're gonna look back at the question. So we have found the points for, okay, all of the points in and on a rectangle, and we can try to create some equations with these three equations. The first one will be this this kind of proportional equation. So AQ over QB, and then I've written them down, this one. So AQ over QP equals to DP over PA, and you have, these are the lines, and then we can name them as a distance. Okay, we can just think that the distance of AQ over distance of QB is equal to the distance of DP equals to distance of PA. And we notice that AQ, QB, okay, they are on the horizontal, and then PA and DP, okay, they are actually on the vertical, and we can use just find the horizontal and vertical distance easily by calculating the difference, okay, between the x or y coordinate, and then you will get this as a result, this equation. Okay, and then somehow you can cross multiply. Okay, it's just to get rid of the fraction, and you will be able to cancel out the negative pk and leaving out AK equals to BP. And then I'm gonna purposely make this one back into the fraction, which looks like this one. And then you will see this blue one, but don't look at the blue one first. Okay, just focus on the green one, which is the K over B equals to P over A. Later, you will see the use of this fractional form. So we have this first equation, okay, which we were gonna use it later. And then the second one is the rest of them, well, the last two equations, I will just try to make an equation regarding the area. So we have two areas, which is the first one, SPMD. Well, S is this area when we try to, because we have A already, so we just use another letter to represent the area, which is S. So SPMD equals to 9. So we just use the points of PMD. D has a origin. D is the origin, and then M is, we have XM and XM and YM. But in this case, I use the coordinate of M as XY. Okay, as you can see it here. And then I suppose that you all know how to use these this area formula, this cascading formula, shoelace formula whatsoever, and you just be able to obtain two of the solutions, which are negative px or positive px equals to 18. Okay, now logically speaking, p and x, they are both greater than 0, because in our diagram, as you can see, if you look at the diagram back, we are in the first quadrant of the coordinate here. This entire region, we are in the first quadrant. So everything, well, first quadrant, which is like so. This one's the first, second, third, and fourth. And everything inside, or just on the axis of the first quadrant of x and y, they are all positive. They contain positive values. So if you have a positive area, and of course you must have a positive area, and so you have the value p and k, which are positive. And so they must have no negative, okay, values. And so when we use the negative 1 multiplied with px, you must get a negative number, definitely. So we can eliminate somehow negative number and leaving the positive answer, which is px equals to 18. This concept is similarly applied in the area of SCMD, okay, which gives you this one, okay, and then you use the same concept, you will get this answer. So you have I'm gonna highlight these two answers, which is this one and this one. I mean these two equations, and also this one. Sorry. So how are we gonna use them? We're gonna deal with the method such that, well, we try to reuse the x and y. Recall back that x is actually the xm, and then y is also the ym. Just substitute the xm with this one, this entire thingy, and then ym with this entire thingy, fraction thingy. And then it becomes more complicated. But it's fine, because what I'm gonna do is I'm gonna divide this entire thing with this thing, because I'm gonna get rid of, well, instead of having two fractions separately, and you can just have one fraction by via the division. So you divide them, you might have you can just cross out this one, and then you will have this one as a denominator and this one as a numerator. I think I should highlight this. So this one as a denominator and this one as a numerator. Sorry, this one as a denominator, the green one, and then the blue one as the numerator. Okay, but in this case I somehow exchanged because I want to get a bigger number on the top, which is the 32. So I instead I used b times abp as a numerator, and then p times pbk as a denominator. Okay, the green one, which is here, and then the blue one on the top. And then if you try to simplify 32 over 18, you will get 16 over 9. Okay, and then you will have as a result the simplest fraction on the right hand side, which is this one. So we might be familiar with this one. So look at this equation, which is this yellow highlighted one. I'm gonna copy down back. Okay, so as you can see, you have this yellow thingy here, which might help you right now. It's gonna help you right now. So if you try to separate this fraction, you will get, actually it's just a product of, in this case, AP times BK. So, and using this yellow thingy here, we can just manipulate it into B over K equals to A over P. Yeah, this is also correct. For example, I give you concrete numbers. If you have 1 over 2, well, 1 over 2 equals to 2 over 4. Right, because if you try to simplify 2, 4, you will get here 1, and then you will get here 2. And so if you try to raise this thing, both of them with negative 1, meaning that you're going to inverse them, you will get 2 over 1 here, and then equals to 4 over 2. So yeah, when you try to make, you try to turn these numbers upside down, and then you will get 2 over 1, 4 over 2 here. You will get here on the left hand side 2, right hand side also 2. It doesn't matter as long as they are fractions and then they are equal to each other. And so you can just get this one finally. And then, yeah, surprisingly, we have BK here multiply with AP. They are just same. So we don't have to substitute them with this fraction. Instead, as you can see, the blue one, which is on the top here, I use the ratio r, okay? The ratio r here, so that my work is appears to be a lot of easier. You see, just use r and then times r, you'll get r squared equals to 16/9, and then r equals to 4/3, like so. And then you have r, which is nothing but b/k, and it also equals to a/p. So you can just use one of the b/k, for example. So b/k equals to 4/3, excuse me, and then a/p equals to 4/3, and you have the fourth and the fifth equation. And so you're gonna try to think, oh, it doesn't really help, right? So as you can see, it helps, because I'm gonna use one of them to actually substitute back into xm, or into one of the areas. In this case, I'm gonna substitute in area this PMD1, okay, as PMD equals to 9, which I've already solved it into this one. Okay, so recall back, P times xm, okay, the x coordinate of m equals to 18. And xm, if you try to recall back from the top here, you will have this one. So just substitute this one, you will get this green thingy here. Okay, right. Now you're gonna use the entire thingy, fraction, the very complicated fraction here. Okay, and then you just try to put it, I'm gonna copy them down. So PBK over AB plus PK equals to 18. So recall back, we have b/k equals to the r equals to 4/3. Okay, we're gonna use this one. Well, I just make it in another way around. B equals to 4/3k, and then what can we get is, as a result, p squared times bk over ab plus pk equals to 18. And then one more thing I'm gonna do is AP. So AP equals to 4/3, and so A equals to 4/3P. And so you can see here, these are two essential things. I'm gonna use them, *1 and then *2. Okay, and so I can just substitute B in terms of K and also A in terms of P. So P squared times 4/3K times K, and then over A, well, which is 4/3P times the B, 4/3K times plus PK equals to 18 in this case. And so I realized that I can cancel PK from the top. Well, PK, if you try to look at it, P squared times K squared, you have PK times PK. And so you can cancel PK on the top. And then here, this expression has a common factor of PK. And I can just cancel them, resulting in 4/3PK on the top. And then here, 4/3 squared plus 1 equals to 18. And actually, you can just get, PK. Huh? Well, you might wonder, why should I get PK? It's really weird. In fact, I don't want to get PK because you have this is the fraction that I'm gonna use it. So what do I mean? So look at the question back. What this question exactly wants. They want us to find area of ABCD, B, C, D. Okay, so ABCD is a rectangle, so we can just use the area of rectangle, which is the base times height. Sorry, the base times, I mean the length times width. Yeah, the length times width. And we know that the length is CD or AB. So we have found the horizontal distance is nothing but B. Okay, it has a distance of B. And then here we have a distance of A. And so the area equals to, well, ABCD equals to AB. So we had just done the substitution of AB in terms of P and K respectively. And so you can see here, which is this red one, AB, and then I get 4 over 3 entire square PK. And then if you try to recall back that I want to actually find the 4 over 3 PK, okay, and then we actually have this inside this red expression by just separating the 4 over 3 square into 4 over 3 times 4 over 3. And so you can get this thing. Okay, so this one equals to the red one. Right, and so we can just find 4 over 3 pk from the left equation, which is this one. So yeah, sorry, not this one. I mean this one. Haha. Okay, this one. You can just get the 4 over 3 pk, and eventually you will find that 4 over 3 pk is a number. And multiplying that 4 over 3 pk, the number, with 4 over 3, you will get 66 and 2 over 3, 2/3, which is the final answer for S ABCD, or the area of ABCD. So I'm gonna recall back what we have done. First and foremost, we have set out the points. We have labeled each point with, well, with constants, and then we try to find M using the straight line and then the point of intersection by finding the equation PC and then DQ. And then we try to use the 3 equations as our tools to simplify the problem, which are this first, the proportionality equation, and the second one, PMD equals to 9 and the CMD equals to 16. We try to somehow get the yellow thingy here. Okay, these yellow 3 thingy here, which are very important for simplifying the problem. And then we try to divide the two yellow thingy here. We will get another simplified solution, which is 16 over 9 equals to AP times BK. And then we recall back that from the first yellow thingy here, we have the similar ratio, which are the B over K equals to A over P. And then we name it as the ratio R. We find the ratio R as 4 over 3. Well, why is 4 over 3 but not negative 4 over 3? Because in this case, we have positive numbers. Okay, remember we are in the first quadrant, and everything in the coordinate in this case, in the Cartesian, on the Cartesian plane, this first plane, we have only positive numbers here, and so our R must be also positive. And then using the fact that R equals to B over K equals to A over P, we can equate that B over K or A over P equals to, well, to 4 over 3. And then we use, again, one of the area equations. We use the PXM equals to 18 in this case, and then we try to manipulate them somehow by substituting B equals to 4 over 3K and A equals to 4 over 3P, and then you will get everything in terms of PK, okay, canceling the PK common factor, and then you will get 1 PK left, and then you'll get 4 over 3 pk, and then you use the fact that the area of ABCD is a rectangle, and we know that it just the horizontal times the vertical, A times B, and then you have remembered that A and B, they have been substituted with 4 over 3k and 4 over 3p, and then you will have this red thingy here, and then you remember that we have got a value of 4 over 3 pk, this on the thick one, this one, and then you have final answer, which is 66 and 2 over 3. Thanks for watching this video, and please subscribe to my channel.